Major and trace minerals. Minerals are vital for health. In India, iron deficiency anemia remains a major health issue. Rising bone fractures in the elderly highlights the need for adequate calcium and sunlight exposure, while high blood pressure underscores the importance of moderating sodium intake. Rather than relying on supplements, choosing mineral-rich foods and limiting salt is the key to meeting the body's mineral needs and supporting overall well-being. Nature and composition of minerals. Minerals are inorganic substances found in all body tissues and fluid. Unlike carbohydrates, fats, proteins, and vitamins, minerals are not organic. They do not provide energy and are not destroyed during food preparation. Mineral distribution in the body. Minerals make up 4 to 6% of adult body weight, or about 2 to 3 kilograms. Major minerals such as calcium, phosphorus, potassium, sulfur, sodium, chloride, and magnesium are make up of 90%. The rest are trace minerals found in the very small amounts. Location of minerals. Highest concentration of minerals are found in bone and teeth, also found in soft tissues such as muscle and nerves and body fluids. General function of minerals. Minerals can maintain acid-base balance, control water-base balance, it enable muscle contraction, support normal nerve responses, it aid blood clotting, work together with other minerals and organic compounds. This table shows the composition of minerals in the adult human body. Bones and teeth formation. Calcium, phosphorus, and magnesium are essential for ossification or bones formation. Most bone formation occurs in the late pregnancy. Bones serve as mineral reservoir and to maintain blood mineral levels. Teeth form before birth and cannot repair once damaged. Soft tissue components. Minerals such as potassium, sulfur, phosphorus, and irons are key structural components of soft tissues. Minerals as cofactor. Sulfur is a component of thiamine and coenzyme A. Cobalt is a part of vitamin B12. The zinc is found in carbonic anhydrase and needed for insulin synthesis. Iodine is essential for the hormones thyroxine. Calcium is a cofactor for pancreatic lipase. Role in the nerve and muscle function. Sodium, potassium, calcium, and magnesium regulate the nerve response and muscle contraction. They control movement of material across the cell membranes.
Control of water balance. First, minerals like sodium and potassium play a major role in maintaining water balance inside and outside our cells. Potassium is mostly found inside the cells while sodium is mainly outside. The correct concentration of these two minerals ensures that water moves properly in and out of the cells to keep them functioning normally. Next, minerals also help maintain the body's acid-base balance. Our body needs to stay within a narrow pH range of 7.35 to 7.45 to function properly. Minerals work together with hormones to regulate this balance and keep the pH stable at all times. The body constantly breaks down and rebuilds tissues, and minerals are continuously moving in this process. We call this dynamic equilibrium. To maintain proper mineral levels, the body uses 3 main mechanisms. First, releasing minerals from storage areas like the bones and liver. Second, adjusting absorption in the digestive tract depending on the body's needs. Lastly, excreting excess minerals through the kidneys. Hormones help regulate the mineral levels in the blood to ensure balance. The recommended dietary allowances for minerals vary depending on age and life stage. Children and pregnant women need more minerals because of growth and development. Unlike macronutrients that are absorbed efficiently, minerals vary in bioavailability. For example, iron may be absorbed at only 5%, calcium at around 20%, while sodium is absorbed almost completely. There are also several factors that can increase or decrease mineral absorption. First is the absorption is improved by body needs, higher in pregnancy and childhood. Second, acidic conditions such as the presence of lactic acid from lactose. Third is the vitamin C, which enhances absorption of calcium, iron, and zinc. And third is the form of the mineral, such as heme iron from animal foods, which is absorbed better than plant iron. Next is the absorption is reduced by first, substances that form insoluble complexes like oxalic acid, phytic acid, and excess fiber. Second, excess minerals, especially from supplements, which compete with each other. Third is the diarrhea or laxative use, which decreases absorption time. And lastly is the intestinal parasites, which commonly cause iron deficiency in children.
Calcium toxicity. Toxicity from natural foods is rare. But why calcium toxicity is rare? Natural foods don't contain dangerously high levels of minerals. Toxicity usually happens when someone takes too many supplements mistaken supplement dosing or substitution, industrial exposure to toxic chemicals, children accidentally ingesting iron pills, or even common substances like table salt can be toxic to infants if consumed in excess. Body functions of calcium. 99% of calcium is stored in bones and teeth. Because calcium's main job is to give our skeleton strength and structure, the bones act as a storage bank for calcium that the body can use when needed. 1% in soft tissues, blood supports vital functions. Even a small amount is important because calcium helps with muscle construction, so our heart and muscles can move. Nerve impulses, so signals in the body travel properly. Blood clotting, so the ones stop bleeding. Enzyme activation to help the body digest and process nutrients and help vitamin B12 absorption. Food sources. These are the food sources of calcium. Milk products, cereals, green leafy vegetables, fish and seafoods. Utilization of calcium. Calcium is mainly absorbed in the small intestine. Vitamin D, vitamin C, and lactose help increase absorption, while oxalic acid, citric acid, too much fat, and too much fiber can reduce absorption. The body only absorbs only about 10 to 40% of the calcium we eat, but hormones like parathyroid hormone, vitamin D3, and calcitonin help keep our blood's calcium stable. Recommended dietary allowances. RDA varies by age and physiological state. Population can adapt to low calcium intakes like 500 milligram per day, but higher calcium intake needed during pregnancy and lactation because the mother needs more calcium to support the baby's bone development and to maintain her own bone health. Maintain ratio of 1:1 because too much phosphorus can interfere with calcium absorption. A balanced ratio keeps bones strong and maintains normal body functions.
Effect of calcium deficiency. First, in pregnant women and nursing mothers. Calcium is pulled from mother's bone to supply the baby or to produce milk. These lead to weaken the bones and increase the risk of porous or osteoporosis later in her life. Second, in adults, especially to elderly women, bones become porous. High risk of osteoporosis, bent back, reduced high, and easy fractures, especially in hip and wrist part. In children, poor bone mineralization leading to ricket. The symptoms of this: bowed leg, enlarged joint, beaded ribs, and weak bones. Teeth form poorly and blood may not clot normally. Other example of that: gum bleeding, high risk of dental caries in early age. Next slide is, this table shows that recommended daily calcium intake in milligrams for different age and physiological groups. In men and women, they need 400 calcium milligram per day, and pregnant and lactating mothers need 1000 milligram per day. An infant needed 500 milligram per day. Also in children that aged 1 to 9 years old needed 400 milligram per day. To 10 to 15 years old needed 600 milligram per day of calcium. Also to 16 to 18 years old needed 500 milligram per day of calcium. Well, calcium needs vary by age and physiological condition. Children and pregnant women required more calcium to support growth and development, while as adults needed it to maintain bone health and prevent deficiencies. Next slide. Magnesium food sources. Magnesium is abundant in many plant foods. The best sources of it is green leafy vegetable. Green leafy vegetable are the richest source of magnesium because magnesium is part of chlorophyll. Also, in plant foods in general, we have legumes, nuts, seeds, whole grains, and vegetables. Plants stored magnesium in their seeds and use it in chlorophyll to capture sunlight. That's why beans, nuts, grains, and green plants are such a powerful sources of magnesium for us.
Iron trace elements. Iron importance. The total body iron is only 2 to 3 grams but essential for vital functions. It combines with protein to form hemoglobin. The hemoglobin carries oxygen from lungs to cells and returns some carbon dioxide to the lungs. Iron is also found in muscles and enzymes that regulate oxidation reduction reactions. Iron storage. Body storage sites is stored in the liver, spleen, and bone marrow as ferritin. Men naturally store more ferritin than women. Ferritin is the main storage form. Ferritin acts as the body's iron reservoir, releasing iron when needed for hemoglobin formation or other metabolic functions. It keeps iron in a non-toxic, soluble, and readily usable form. Iron reserves and gender differences. Men have higher ferritin stores than women due to the absence of monthly menstrual loss. Women of reproductive age tend to have low reserves, increasing the risk of iron deficiency. The role of iron stores. Stored iron supports hemoglobin production, muscle or myoglobin activity, enzyme function, and immune response. Food sources of iron. Animal source. It is mainly found in eggs, liver, and meat. While in plant sources, it is found in leafy vegetables, whole wheat flour, rice flakes, Italian millet, pulses, peanuts, bajra, ragi, jowar, and parboiled rice. Absorption factors. It includes soluble form, acidity, and vitamin C, while it reduces high cereal diets rich in phytates, low calcium, and low ascorbic acid. Utilization and absorption of iron. How the body meets iron needs. Reutilization of iron from old red blood cells, absorption from diet, and use of stored ferritin. Absorption occurs mainly in duodenum and small intestine, only 3 to 10% absorbed in healthy adults. Higher absorption during growth, pregnancy, and anemia. Excess iron is stored in intestinal mucosa as ferritin. Iron is a one-way element because of it is reused from red blood cells breakdown. Recommended dietary allowance of iron. For men, 60 kilograms need 28 milligrams per day. For women, 50 kilograms needs 30 milligrams per day. Pregnant women needs 38 milligrams per day, while lactation needs 30 milligrams per day. In children, 1 to 3 years needs 12 milligrams per day. 46 years needs 18 milligrams per day, while 7 to 9 years needs 26 milligrams per day. In children, boys that is 10 to 12 years needs 34 milligrams per day. Boys between 13 to 15 years needs 41 milligrams per day. Boys with 16 to 18 years needs 50 milligrams per day, while in girls, 10 to 12 years needs 19 milligrams per day. Girls 13 to 15 years needs 28 milligrams per day, and 16 to 18 years needs 30 milligrams per day. Iron deficiency. Prevalence, very common, 45% in adult males and 70% in women and children. Causes, low dietary iron, folate deficiency, especially in children and pregnant women. Its effects are low hemoglobin or anemia, fatigue, faintness, poor oxygen transport, and reduced ability to work, study, or participate in activities. Its impacts affects children's learning and play, affects women's health during pregnancy and nursing, and it reduces work capacity in men. Iron overload, excess iron absorption. Too much iron leads to deposits in liver, lungs, pancreas, and tissues. Hemochromatosis, genetic disorder. Excessive iron absorption causes organ damage and skin pigmentation. It may also lead to liver cirrhosis. Hemosiderosis, excess iron storage without tissue damage, caused by prolonged unnecessary iron supplementation or abnormal red blood cells breakdown.
Iodine. A small amount of iodine is required to keep our body healthy. There are about 25 to 30 mg iodine in the body. Of this, about 33% iodine is present in thyroid gland, but iodine in minute trace is found in all cells of the body. Two hormones produced by the thyroid gland, thyroxine and thyroxine, contain iodine. The amount of iodine in plant is depend on the presence of the mineral in the soil. In the mountains area like Himalayan regions, the iodine from the soil is washed away by rain and melting snow. Plants that grow in this region are very low in iodine content. Similarly, the salts mined in the sea areas, known as rock salt, do not contain any iodine. The water of the ocean contains iodine. The sea plants and the fishes which feed on the rich source of iodine. Salt obtained from the sea contain iodine. Vegetables which are grown in soils containing iodine are also good source of iodine. Other trace elements. Copper is associated with iron in energy production. Zinc is an essential part of cell enzyme system. It combines with insulin to form a storage form of the hormones. It is important in the immune system as part of white blood cells. Selenium functions as an essential part of an antioxidant enzyme that protects cells and their membranes against oxidative damage and hence against cancer. In this way, it spares vitamin E. It is also credited as a protective agent against mercury poisoning in animals. Reduced blood selenium values have been reported in children suffering from protein-calorie malnutrition. Major and trace minerals. Cobalt. The only known function of cobalt is its association with RBC formation as part of vitamin B12. Fluorine is necessary for resistance to dental caries. It may have a function in prevention of the bone destruction associated with aging. Molybdenum function as catalyzed component in several cell enzyme system. Manganese, like other trace element, its function as an essential part of cell enzyme.